Hi there, welcome to part 3 of the circuit analysis basics. In this part, I'm actually going to be talking about a new thing, the diode and the light emitting diodes. And those are actually going to be the very last thing I'm going to be talking about, as I'm not going to be talking about transistors, MOSFETs, and thyristors and those kind of things. No. I'm not going to be talking about them. At least right now. I don't know, maybe in the future, but definitely not now. So, the idea behind the diode is the following. So let's just draw the symbol of a diode and first thing first. Let's say that we have, I don't know, like a generator here with a plus and minus, and then we have a resistance here for whatever R, our generator with V. This is gonna have a certain resistance since ohm, and then we're gonna have, I don't know, the diode. Okay, so the diode gonna be something that looks roughly like this, and then is connected back to the generator. Now, what does the diode do? Well, the diode is actually a component that, well, let's suppose that we have a certain difference of potential, so a certain amount of volts. So the current is flowing this way, it's getting through the resistor, and it's getting here to the diode. Now, the diode is actually very useful because it's letting only the current that is polarized in the right way, the way it's oriented, go through. So when you see this symbol here, it looks like a triangle with a line here. So in this case, the triangle is pointing down here, okay, and therefore the circuit is perfectly fine, and the diode is going to let the current go through and get back to the generator. So in this case, the diode is just going to let the current go through. But the diode can actually be used to stop current. And if we had the very same circuit, so with a generator, something like the resistance, and then the diode, but in this case, oriented in the opposite direction, then in this case, the current would not, go through, because it will be like, it will say like, okay, I'm just trying to get through here, but here I'm gonna face the diode polarized in these directions, so pointing upwards, and the diode is not gonna let the current go through, so you're gonna stop the current, and it, it's like having an open circuit. The current is not gonna flow. So there is no way the current is gonna flow and go back to the generator. No way. Here is just gonna be, it's just gonna stop. So this doesn't happen, and this doesn't happen. Current doesn't flow. Current doesn't flow. Okay, so no, current doesn't flow. This doesn't happen. In this case, yes, it's polarized in this way, but in this case, no, it's polarized upwards, so the current doesn't flow. Now, this is true to a certain extent, in a sense that in the real world, we can actually make current go this way through the diode anyway. But it's not very convenient at all, because each and every diode has a certain threshold and if we exceed this threshold, we can actually let the current go through. So think about the diode kind of like a very, 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 very big resistance that is actually gonna stop the current from getting here. But if we exceed this resistance, then we can, make the current go through. But it's not very convenient at all, because let's suppose that the diode is oriented this way, the current is just gonna flow and go back to the generator. While here, let's say that we have, I don't know, like 12 volt here. If we have 12 volt here, for instance, and the diode is big enough, we're not gonna, the diode is not gonna let the current go through. Perhaps we will need, I don't know, like 400 volt to get through this diode, which is polarized in the opposite direction, which is not very convenient at all. But this is from the real world. In circuit analysis, we're not going to consider this. In circuit analysis, if a diode is oriented opposite to the flow of current, the current is not going to pass. There is no way the current is going to pass. There is no way the current is going to get through here. So basically, what a diode does is either letting through the current or opposing the flow of the current and stopping the current from even flowing. So this is pretty much it about the diode. The characteristic, could be drawing the characteristic of a diode. Sometimes you are asked to plot the characteristic of a component, and what this basically means is that you have to plot in the xy plane, which just becomes the vi plane, what basically happens. For instance, for resistance, so for the resistance, if I have to plot in the xy plane, I will have something like this, going in this quadrant and in this quadrant here. If I had to plot the diode, I would have something like this, like this, only like this, but I'm not gonna be plotting here. It's behind the point I'm trying to make. As I said, this is just gonna be a general overview about the diodes. So as far as I'm concerned, all you need to know is that the diode is either gonna let the current go through or stop and oppose the flow of current and stop and prevent it from even flowing. And you might be wondering, okay, fair enough, but why is this useful? Why do I want to stop the current from flowing, for instance? Well, the diode is extremely useful. But I cannot tell you why, because I haven't introduced the AC and DC current yet. We're only working in DC. But as a very, 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 very quick overview, the diode is actually very useful because it's used as a rectifier to basically make AC current direct current. So basically in the AC, I'm not going to be talking about AC, I'm going to have a full section dedicated about AC, so a full video, but just like to have something to wrap your mind about. In the AC, you basically have, let's say at 50 hertz or 60 hertz, you basically have the current going, alternating, so going in one direction and back to the other direction, and this direction, the other direction, this direction, the other direction. So if you use diodes and you combine them, you can actually force the current to go in just one direction, or like for instance just in this direction, or and not go back to this direction and so on. And if you put a bunch of these together, and together with capacitors and so on, you can actually get a very good rectifier to get DC out of AC. But this behind the scope of this video. I'm not going to be talking about AC anymore. This is just you will see it. You will see. I promise you that I'm going to draw a circuit, a rectifier, in which you're going to see why the diode is useful. Now, sometimes in a circuit, you might see the diode slightly different. You might see something like this, like plus minus, I don't know, a resistance just for the sake of having one. And then something like this, okay? But with those two things. So those two little arrows, which are not like pointing straight, but just pointing here. I know they're difficult to see, but I'm just gonna try to make them. Yeah, I made them worse. But anyway, if you see this, okay, this is just not a diode. Is a light emitting diode. So basically an LED. Okay, so this just stands for a light emitting diode, and this one is a perfectly valid circuit. For instance, you have a certain source with a certain amount of volt. Perhaps you have, I don't know, 12 volts. Okay, and you say, okay, this is a light emitting diode, so basically whenever current flows through here, this diode is gonna emit light, make light visible. But you don't want to burn it, because getting all the 12 volt straight to it will probably burn it. So you want to have a certain resistor of a certain amount of ohm, I don't know, something, in order to prevent from burning it. So the current is going to flow through here, get into the resistor. A little something is going to be dissipated through heat because of the joule, and then the current is going to flow here, and the diode is going to emit light, photons, visible photons. So yeah, whenever you see this, this is just a light emitting diode, so an LED. We LED are spread everywhere. They are in your mobile phone probably, when you get a notification like you see something that it's it's like it's bright and it's going and turning on and off, on and off, and off, and it is literally a power source, resistance, and an LED, for instance. So that's an LED. And there are many useful things you can do with an LED, and they're spread everywhere across devices. So yeah, this is pretty much about it. I'm not gonna talk any further about diodes, but this is the general idea. So diodes can either let the current go through or stop it. And if you see diodes written this way, I'm sorry, drawn this way, then it means they're light emitting diodes, so LED. So if the arrow is pointing in this way, okay, it's just letting the current go through this way, the way it's pointing at. If it's pointing this direction, it's only gonna let the current go through in this direction, is this pointing in this direction, and so on. You know, you basically got the general idea here. So this is pretty much it. Very, very, very basic stuff. And yeah, I'm gonna have one more lecture, and then I think we're gonna start to see a few problems.